Okay, last video on Friday, so this will be about 45 minutes worth of videos, maybe a little less, so that get you done for the week. And if you can come back knowing this, we're ready to start the next lab. As a matter of fact, I have a video already made for describing the next lab, but you don't, some of you have your lab books. So we could do that remote if we had to. All right, so on to page 25. I'm sorry, number 25, page 384. Describe the main reason why a reaction between two substances comes to an end. You run out of one of them, reaction can't go anymore. Just like if you have, I gotta make spaghetti sauce here coming up in a week. I gotta make a list. My wife already told me to make a list of what we need. If we run out of something, that's all the spaghetti sauce you can make. You can't make more. So unless you want it to taste bad, or you could do other things, like when a reaction stops because you run out. Sometimes other reactions can go, but that reaction is done. Number 26, identify the limiting and excess reactant in each reaction. Wood burns in a campfire. Well, the wood is burning with the oxygen in the air, and one campfire is not going to burn up all the oxygen from the air. So the oxygen is the excess, and the wood is the limiting. 26b, airborne sulfur reacts with the silver plating on a teapot to produce tarnish or silver sulfide. Yeah, this is very effective. You'll run out of silver teapot long before you will run out of sulfur in the atmosphere. There's a lot of it there. Especially if your water contains sulfur. If your water contains sulfur, it'll gobble up all the silver in your house eventually. If there's silver solder in the computer, it'll eat a computer like nothing. So be aware of that. When you buy a house, if there's sulfur in the water, it doesn't mean you can't get it. It just means you have to maybe remove it or something, or store silver separately or something like that. Baking powder in a batter decomposes to produce carbon dioxide. Okay, baking powder can actually be different things, whatever that is. This is the only reactant, so when it runs out as limiting, then the reaction stops. Two common ingredients in baking powder are sodium carbonate. This is usually in baking powder the most common example, Na2CO3. Now if you heat that up, you will break that down and produce some carbon dioxide. So you could make CO2 and have maybe NaO, maybe Na2O. Another example of something that is sometimes in baking powder is baking soda. So we did the reaction just the other day with baking soda, put an acid in it, mixed it in chloride, carbon dioxide, water. You can, in a recipe, add an acid like acetic acid, which would do this. Or maybe the process of putting together whatever you're baking makes its own acid. Maybe a lactic acid, maybe a yeast makes lactic acid or something. It can break this down. So there are some examples. The point is when you're out of the baking powder, the reaction stops. There's one reactant. It is the limiting and the excess reactant. Okay, on to number 27. It says tetraphosphorus trisulfide, which is P4S3, is used in match heads. It's produced in the reaction given here. Whoops, what happened? Given here. 8P4 plus 3S8 gives you 8P4S3. Determine which of the statements is incorrect and rewrite the incorrect ones. So in the first one, we want to determine whether or not this is incorrect. 4 moles of P4 react with 1.5 moles of S8 to form 4 moles of P4. That one is okay, because if you look at the balanced chemical equation, you could have numbers of molecules, and these are molecules, molecules, and molecules. If you want to see S8 at some time, I can show that to you. It should be in here, maybe it's not. That's 8, 3, and 8. So if I have 4 of these, I'm going to have 4 of those, and half of 3 is 1.5. So these numbers are okay. That one's right. We don't have to rewrite that one. Number 2, sulfur is the limiting reactant when 4 moles and 4 moles react. Okay, if this is 4 and this is 4, now this is the limiting reactant because it's 8 and 3. Now we don't even need to look at grams on this. So if I have 4 of this, I'd have, well, 1.5. And I've got 4. So this is most definitely excess. And this one's the limiting. So S8 is excess and phosphorus is limiting. So that's how you need to change that one. And the last one, 6 moles P4 reacts with 6 moles S8 forming 1,320 grams. Well, let's take a look here. There are different ways to do this. It looks like all I did was first of all say, I know that this is excess. Because if I have 8, I need 3. If I have 4, I need 1.5. If I have 6, I need something less than 6. What, 4 maybe? I'm not even sure. It'd be 3/8 of 6, whatever that is. Okay? So I know this is excess and this is limiting. If you don't know how I know that, just rewind that and look, or I'll explain it on Monday if you ask. So I know this is excess because if this was, 6 moles, it'd be a lot more of this that I would need. So this is limiting. 6 moles P4, we're going to change moles to moles of product, and then grams of product. So we'll check it out. So I'm going to change moles P4 to moles P4S3 to grams P4S3. So I'm doing moles to grams. That's 2 arrows. That's 2 sets of parentheses. So I'm going moles P4 to moles P4S3 to grams P4S3. This goes here. This goes here. 8 moles of P4 to 8 moles of P4S3. And if you add up 4 phosphorus and 3 sulfur, you get apparently 219.6. You can, in this case, cancel those. 6 times that is 1320. So this is a correct statement. You don't need to redo it. So see you Monday.